Okay, so this is section 4-4 in chapter 4, and we're going to be continuing with the same topic of evaluating these trig functions. And so now we can talk about any circle, not necessarily just the unit circle. So before we were talking about the unit circle with a radius of 1, but now if we're talking about any circle with a radius of r, this is how all of those evaluating those angles would go. So instead of sine just being the y value, it'll be y over r. And cosine will be x over r. And tangent actually ends up staying the same because we didn't use the radius. You might also be calling the radius the hypotenuse of a triangle. Okay. Now, if this is our coordinate system here, remember we said all trig functions are positive, sine and cosecant are positive here. Tangent and cotangent are positive here, and then cosine and secant are positive here. So all of them are positive here, and quadrant 1, 2, 3, and 4. Okay, this is something that you're going to need to know and is going to be helpful for you. So let's look at our first example. Now we have some point here, and again, it's not the unit circle. So what I'm going to do is just start to draw that angle. Well, the point 1, -3 would be 1 and -3. That's our point P. So it's in quadrant 4, and this is the terminal side, and this is our angle theta. Now what we can do here is we can start looking at this triangle that's created here, and we can use that to evaluate. Or you can use your x and your y values. But we still need to be able to find our radius here. So r is going to be equal to, or r squared using the Pythagorean theorem, 1 squared plus 3 squared. This distance is 3, this is 1. And so we have r squared equals 10, so r equals the square root of 10. And so what we can do now is evaluate all of those using what we have above. So sine of theta is going to be y over r. So our y value is -3 over square root of 10, which if we rationalize is going to give us -3 root 10 over 10. And then cosine, we'll have x over r, so x is 1 over root 10, which will give us root 10 over 10. And then tangent is going to be y over x, so -3 over 1, which is just -3. And then these are the reciprocals, so this will be -1/3, this will be root 10, and this will be negative root 10 over 3. Okay. You could have also just used the triangle to evaluate it using this as our angle theta. Those are your options there. And now let's talk about what are called reference angles. So we've been kind of using this idea of reference angles with this triangle that I've been drawing. However, we can kind of formalize it now. So if we're letting theta be a non-acute angle, so it's got to be bigger than 90 degrees in standard position, that lies in a quadrant. Its reference angle is the positive side of the angle and the x-axis. Okay, so if this is my angle here, this is theta, then my reference angle is this angle here, the terminal side and the x-axis. That's theta prime. That's my reference angle. Now, I'll just write that. Okay. Now if this is my angle, now it's in the third quadrant. Here it was in the second quadrant, now it's in the third quadrant. We're using that terminal side and the x-axis, and this is my reference angle. Now oftentimes the mistake that people make here is they'll go from the terminal side to the y-axis and say that's theta prime. That is wrong. Don't do that. It's always going to the x-axis. This is your reference angle. And then the last one, if theta ends up in quadrant 4. Our reference angle is the terminal side and the x-axis, and so this is our reference angle. Now the really cool thing about reference angles is this angle here and this angle here can be evaluated and we'll get the same answer. Okay, so let's go ahead and flip the page now and put this into practice. So it says find the reference angle for theta for each of the following angles. So let's go ahead and I'm just going to set up a graph really quick for each of these. And here we have 345 degrees. So this angle is going from here all the way almost to 360. And that's theta. So then theta prime, our reference angle, is right here, and that would be 15 degrees. Okay. We have theta here, 5 pi over 6, which, because it's on our unit circle, we know exactly where that's at. So that's our theta. And then terminal side to the x-axis, this is going to be theta prime. And this is pi. Pi minus 5 pi over 6 gives us pi over 6. Okay, so that's our reference angle. Next one, negative 135. Well, positive 135 is right here. So going that same amount, but in a negative direction, is going to be right here. That's theta. Terminal side to the x-axis is going to be our reference angle. So that would be 45 degrees. Now this last one is the toughest one. Most students think because this is a decimal here, a number, that this is all of a sudden now degrees. But there's no degree symbol there. This is in radians, where your pi has been multiplied out. So this would be 0, and pi over 2, well, 3.14 divided by 2 is 1.57, and this is 3.14. I'm going to zoom in on this. And then 3 over 2 pi is going to be 4.71, and then 2 pi is 6.28. So 2.5 is going to be in here. That's theta. And then we're trying to figure out what our reference angle would be. Well, 3.14 minus 2.5 is going to give us 0.64, and that's our reference angle. Okay. I'm going to go ahead and move that up again, and I'll zoom back out for you. Now, what do we actually want to use reference angles for? Finding reference angles that are for angles that are greater than 360 or 2 pi and less than 360 or 2 pi. So here's some steps, and I'll let you guys read those on your own, but there's really only 1 or 2 extra steps for these. So here we have an angle that is bigger than, or I guess smaller than negative 360. And if I'm going to graph this angle here, we can first find a coterminal angle. So we want that coterminal angle. So negative 580. And we can add 360. And if we add 360, that still gives us negative 220. So let's add 360 again. And we end up with 140. Okay, so that's a coterminal angle. So that would end up being about right here. Okay, that's 140. And then what we can do is find our reference angle. And our reference angle will be 40 degrees. Okay, let's do another example with radians. If I have here 8 pi over 3, that's bigger than 2 pi. So 8 pi over 3 minus 2 pi, but I'm going to write it as 6 pi over 3. That'll give me 2 pi over 3. That's right here. So then my reference angle is going to be pi over 3. Okay? So that's how we do it if our angle is bigger than 360 or less than negative 360. So actually using reference angles to evaluate trig functions now. Let's go through a couple of these examples. So first we have sine of 300, and we're going to graph that point here, or that angle. 300 degrees is about right here. So this is theta. So first we want to find our reference angle. Well, if this is 300, theta prime is going to be 60. And the second thing is evaluate using the reference angle. So sine of 60 is root 3 over 2. However, determine the positive negative sign using all students take calculus. So this angle is in quadrant 4, and in quadrant 4, sine is negative. So we need to put that negative sign there. And that is our answer. So again, we can use our reference angle to evaluate and then use all students take calculus to determine whether it's positive or negative. Let's do a couple more examples of this. 5 pi over 4. Well, 5 pi over 4 is in quadrant 3. That's my angle theta. My reference angle, which is going to be pi over 4. And then I can evaluate tangent of pi over 4 instead of 5 pi over 4. And tangent of pi over 4 is root 2 over 2. And we can check whether it's positive or negative. In quadrant 3, tangent is positive, so that is our answer. In our last example, we have secant of negative pi over 6. Okay, so negative pi over 6 is going in the negative direction, pi over 6. And our reference angle is actually going to be the same, just positive. Okay, so I can evaluate secant of pi over 6. And secant of pi over 6 is going to be the reciprocal of cosine there. Cosine is root 3 over 2. So secant is going to be 2 over root 3, which when we rationalize gives us 2 root 3 over 3. And in quadrant 4, cosine and secant are positive, so it's positive, and that's our answer. And that brings us to the end of section 4-4.